Hey builders, in this video we're going to take a look at another architecture from early 2017. This time it's New Relic and how they are building modular deployments leveraging Terraform. Terraform was actually released a few years earlier in 2014, but it was not at all what you have grown used to today back then. So we'll see what they ran into, the challenges, what they designed to solve those challenges, and then we'll evaluate based on what we know today, what's available today, how you could improve that architecture, especially using the AWS well-architected framework. Let's dive in. We've still got the retro opening here. You can tell right away with the just the opening sounds. They changed it eventually. It's still cool. I like it.
Welcome to This Is My Architecture.
Oh, first appearance of Matt. Matt is an AWS rock star. I've known him for years. He is leading a massive amount of AWS at this point. I can never keep up. At this point, he was just the architect lead in technical partner solutions. And I say just compared to what he's achieved now. Fantastic guy. And he's going to be talking to Lisa from New Relic here. And we'll see what they've built out around Terraform.
I'm Matt, and today I'm joined by Lisa from New Relic. Thanks for coming, Lisa.
Sure.
So today we're going to talk about how you're using Terraform to deploy your infrastructure. Is that right?
Mm-hmm.
Well, first tell us a little bit about New Relic. What do you guys do?
Sure. So New Relic is a monitoring company. They've been
So New Relic is a huge monitoring company at this point, and they've been going for a few years, a key partner. They were really one of the early ones into monitoring, traceability, and eventually into observability.
really focused on monitoring application performance management, but have recently got into the infrastructure management.
Okay, and you actually have a product called Infrastructure, is
Yes,
that
we do.
right? And that's what you're using Terraform to deploy?
Yes.
So tell us how that works. Why are you using Terraform in the first place?
Sure. So Terraform is a great open source tool that allows you to create infrastructure with code.
Okay, so right off the bat, we know they're using this on the infrastructure monitoring solution that they have or service that they have, and they are going to be using Terraform because it's open source. And even in that point, I mean, Terraform was stood up because CloudFormation had a lot of challenges. It still has a lot of challenges, so it makes sense for them to be leveraging something like Terraform because they can make improvements. And if you're building a service on that, and you can't improve the core piece of that service. That's a real challenge. So it would make sense, even though Terraform was very usable at this point, having something that you can contribute back to and improve, that's a good thing to base a business on.
So about a year ago, we were a brand new team. We were tasked with, you have to build this new product and you have about a year to do it.
Yeah.
So we had a big time constraint.
To move quickly.
We needed to move quickly, but we're an experienced team.
So they've got a year to do it, so they feel like they're under a time constraint, but you just said they have a bunch of experience. So that's good and bad. Nobody likes a massive time constraint, but also that kind of breeds creativity. Let's see what they had to deal with.
We wanted to make sure we did something that was clean, that was easy to use for new people that were coming on, easy to maintain, easy to audit.
So I'm not sure if she's talking about new people on the team and internally or customers. Either way, those are great design goals to make sure that something is simple to use, that it's clear and easy to maintain. You're going to spend way more time maintaining things rather than writing them. That's just how it is. Always make sure your code and your services and your ideas are very easy to understand and consume after the fact.
Terraform fit the bill for us.
Great. So yeah, Terraform's great for infrastructure automation. The thing about that though, as we started to automate all the infrastructure, now we live in fear of the typo, of the fat finger. If you have this huge stack in production, you don't want one little flaw to kind of wipe it out.
We've all made that typo. We've all had that issue where you rolled something forward and it didn't work because you made a mistake. I'm not sure what they're leading at here, but I'm curious. Where are we going with this, Matt?
How do you guys handle that problem?
Absolutely. So what we do is we modularize as much as possible.
Okay, great.
So at the first level, we
Okay, so what they're doing here is they're modularizing different pieces so that if you do make a mistake, the blast radius is reduced. You would also at this point use a linter. I think there's one available for Terraform. I should probably check that out. But basically something to double check your work to make sure that it's always going to work. But modularizing is a smart move as well because you're making smaller active units, which means you can test them easier. And once they're there, you're making changes in different units. So you're actually reducing your potential risk here.
modularize our environments. Those are in separate directories. And then we have subdirectories within that that houses our Terraform modules. For example, we have our Mesos cluster, Cassandra, and Elasticsearch, and so
Not what you would be building with today, but totally made sense back then. So what Lisa's saying here is that they've got a very logical structure, and under that structure, they have a corollary or correlated Terraform module for that piece of infrastructure. So they're making sure that each thing is isolated, so that if you need to rebuild the Mesos cluster, you can, or you need to rebuild Cassandra, you could. You don't have to rebuild everything; you just rebuild that one piece. It's a good lesson, and it still holds up. Our infrastructure decomposition, it's a tricky subject, but it's important and it's worth investing time in.
Okay.
Each environment also contains like an environment module, which is just hosts our hard-coded values as variables, so for reuse throughout the modules.
Okay. So I see you have this thing, basic role in the middle. What's that?
Basic role is a library that we've written.
Gotta love when you have to write a library called Basic Rule, and that's probably actually the name for it, and I love it for so many reasons.
It's also a Terraform module. Basically, it just abstracts some code away, and each one of our Terraform modules uses it.
Okay, so that makes sense. The basic rule module has a bunch of the simple things that you need across all the modules. So write once and reuse it all the time. And then the sub modules are going to have the customized things for that specific piece of infrastructure. So for example, if you needed to do some sort of centralized logging, you could do that through the basic rule module, and then every other sub module will be able to call that logging thing.
So whenever this is going to be created, it's going to be using what Basic Rule has already created for us, which is a launch config and the associated user data, which is just a script that the instances run at launch time.
Got it.
That's associated with an auto-scaling group, which specifies how many instances need to be running of each cluster at all times.
Got it.
And then it also creates an IAM profile, which makes it really easy for us to attach IAM policies to.
Okay, so remember, 2017, a lot of the stuff you're probably thinking they should be using didn't exist. So what they've done in Basic Rule is set some standard configuration items that are going to be applied consistently across their infrastructure. It's a really smart way to do it. They've decomposed this in a logical way that allows them to make changes that have a minimal amount of risk to the rest of the infrastructure. And that's really key.
When we need to specify those in the individual Terraform modules themselves, but at this level, we're creating policies for things like EC2 describe commands, access to S3, things that all of our resources need.
Great. So IAM is great for sort of the AWS components of.
So they're assuming there's a baseline common architecture that like things are built on EC2, which is fair. Back in this point in 2017, that's probably your only realistic building block. Remember, most of the container stuff we're using these days didn't exist, or it didn't exist at this level of maturity that you would rely on it. So a lot of EC2 instances.
Access control and authentication. How do you actually handle the deployment access control authentication? If you modularize all this stuff, how do you control which users deploy which pieces? I imagine not everybody has access to every part of the infrastructure.
Our team actually does.
Oh, cool.
Yeah,
Okay.
so our infrastructure team.
That's a great setup. I love that. And I don't know if it was a setup or it just came up organically. But Matt was saying, hey, the people who are deploying Mesos may not be able to deploy Cassandra. So how do you handle that? And Lisa said, well, we are all allowed to deploy all this different stuff. And I think they're probably confident in expanding those permissions and those abilities because of the modularization, because you don't have to be doing it every single time. You kind of unify your ops out so that you don't have, oh, I'm the Mesos person, or I'm the Elasticsearch person, or the Cassandra person. Just everybody runs everything, and it's just they only have to run that specific piece at a specific time.
Pretty good sized team, about 10 people. We've got people from infrastructure and operations all the way to UI. I guess our UI people don't have access to it, but everybody else has a hand in maintaining our infrastructure. So we use GitHub Enterprise.
Okay.
All of our code is stored there, including the Terraform state file.
Okay, so you really.
Okay, so they've got everything in GitHub, which is great because that means they version it, which means if you make a mistake, if you do fat finger something, you can roll it back, which is great. That's a really wonderful way to be able to version your infrastructure.
Infrastructure as code
We
alongside the code.
absolutely do. Yeah. So the Terraform state file is managed by Terraform. It keeps track of the state of everything that you've had in your Terraform code in AWS. And so when someone needs to make a change, they make a branch, they make the code change, create a pull request. In that pull request, they include the output of Terraform plan, which is basically a dry run.
Okay, so they're really running, their infrastructure like a development team. And so they'll create a feature branch, roll out a new piece of infrastructure like, hey, I changed the auto scaling configuration. And they're putting out the dry run output from Terraform in there, which is really, really clever because that is clearly illustrating what changes are about to be made. And that is then in their record. So they have a nice audit trail as well. So if they have a compliance requirement down the road, they're actually maintaining all that audit evidence as they go, which is really, really smart. But also if something messes up, they've got an easy way to trace it all back, which is critical.
Here are the code changes, here's what's going to happen. The team has to approve that.
Okay.
Once it's approved, the engineer runs Terraform apply, that actually applies the changes and triggers Terraform to update the state file as well, get the freshest state.
So they actually run it like a pull request in a normal code base, is that if somebody approves it and merges it in, then they'll actually run the changes in production. Cool.
And the team also needs to approve that as well. So that's committed, added back to the PR. Once that's approved,
So another approval layer in there after it's run.
then we merge it into master.
And how long?
And then it gets merged in. So really clear, really simple process as far as it goes with 2 checks, which is always good. So they've not only modularized it to reduce the risk, they've added 2 verifications into the step in changing their infrastructure, which given that they have customers relying on this, it's probably a really smart move.
Kind of end-to-end approval process take?
It's not too bad. We're all in the same location for the most part, and we're respectful of each other's time. So, for the most part, we don't usually have urgent fixes, but if we do, we'll just communicate it. But I'd say on average, it's, I don't wait more than a day.
So they're making these changes within a day because they've put in these approvals, but they have exceptions for emergency systems, which totally makes sense.
To be approved.
Great, so you can have sort of really quick iteration.
Yeah.
Yeah, well, I really like I have that combination of kind of engineers owning both their code and their infrastructure and sort of owning the deployment process, but it's also with these checkpoints so you can make sure that nothing bad happens.
Yeah, it's really easy to.
That's a great point from Matt, and really we'd call that blast radius today, and overall ownership, right? Is that they're really embracing the concept of development and operations merging together into DevOps, in that if you write it, you own it. So the engineers own it end to end. They're double checking each other's work with those little gates, which makes sense. It works for their team, it works for what they're doing, and they're not changing infrastructure constantly. It's not like a code base, even though they're treating it like a code base, where you're making them say, oh, I'm changing the name of this, I'm changing the color of that. Like, it's their core infrastructure that stuff's built on, so they probably don't require changes more often than a day or a couple times a day.
Fat finger, make a mistake, and wipe out an entire cluster. So we really try to limit the blast radius and keep our code as
There we go, blast radius.
coupled as possible. I personally have wiped out our Cassandra cluster before.
That's a bold admission, and kudos to Lisa for making it. We have all done that or worse. We need to stop pretending that we don't.
Thankfully, it was only in staging, but because of the ease of Terraform, I destroyed it with one command, but I also brought it back with another command.
And that's the key. You blew it away by accident, but you also could bring it back with a simple command. And that's really the key takeaway for infrastructure as code. It's repeatable. They've modularized it in a great way here. This is a really smart solution.
Cover quickly.
Yes.
Very cool. I love the modular approach. I love how you're using Terraform. It's a really interesting architecture. I appreciate you sharing it with us today.
And that's key. Matt just summarized it up really, really well. And this has probably stayed much the same. Now, there's a bunch of new features in Terraform that they probably played around with what's in that base role versus what's in the individual structures. But thinking about infrastructure decomposition and how your Terraform files fit together, how you're going to manage that state is really important. But I think for me, the biggest takeaway from this, there's not much that I would change. Obviously, the infrastructure that they're actually deploying is probably radically different, but we didn't get into that. What we're talking about in this video is really that concept of how you manage the infrastructure as code. But my key takeaway from this one, and I would strongly encourage everyone to implement this, is have that clear process flow of how infrastructure changes are made. Who approves them? How many approves do we need? How do we manage that code base of those infrastructure files? Do we do branch releases? Are we merging everything back into main? Like, how is that flow working? We have a ton of experience on the software development side that we can leverage into infrastructure as code, because that as code part is absolutely critical. And if you ignore all those things, you're going to run into problems. But this is a great design by New Relic way back in 2017. I'm sure it's only slicker today, leveraging all the new features and functionality, not only in Terraform, but in the AWS cloud. But that key point is the decomposition and what's the flow to make changes and to roll them back in case of a problem. So like most of these videos, kudos to New Relic. It's a really great architecture. Very cool to see Matt in his early days advocating for this type of design solution. And I will see you in the next video.